In this video, we're going to start the process of developing a nutrient balance sheet by first figuring out the crop nutrient requirements, and then determining the nutrients that are available to the crop regardless of the manure application. Hopefully you've already watched the first video in this series, which was an overview of the process, so you have some context for where we're headed. The whole process begins with determining what the nutrient requirements for a given crop actually are. The best way to do this is with a soil test, because the soil test will take into account the nutrients the crop needs, as well as the nutrients that are already available for the crop in the soil. If you're developing a nutrient balance sheet for an Act 38 nutrient management plan, then soil tests are required. If you're developing a nutrient balance sheet for a manure management plan, or as an Act 49 manure hauler broker, then you aren't required to have a soil test. When you don't have a soil test, you can develop the balance sheet based on crop nutrient removal values, but the manure application rates will be limited to meeting the phosphorus nutrient balance. So, in the first line of the balance sheet, enter either the nutrient recommendations from a soil test report, or if you don't have a soil test, the crop removal values. If you need to determine the crop removal values, use tables in the agronomy guide that give you the N, P2O5, and K2O removal values per unit of yield for different crops. These tables are also reprinted in the Nutrient Management Technical Manual and in the Nutrient Balance Sheet Workbook for manure management plans. Here's an example of getting the nutrient requirements from a Penn State soil test report. Here we'll be developing a nutrient balance sheet for manure applied to a corn silage crop, which is the second crop in the soil test report. Based on the 23 ton per acre yield goal and the existing soil test levels, the nutrient recommendations are 160 pounds of nitrogen, 30 pounds per acre of P2O5, and 0 pounds per acre of K2O. We would enter these recommendations to the top line of the nutrient balance sheet. Now let's say we wanted to develop a nutrient balance sheet based on crop removal values for a 23 ton per acre corn silage crop. We would look at the table in the agronomy guide for N recommendations and see that corn silage needs 7 pounds of N for every ton of expected yield. So our N removal value is 23 tons per acre times 7 pounds N per ton, which gives us 161 pounds of nitrogen per acre. Then we would look at our tables for phosphorus and potassium removal. We see that for corn silage, each ton of expected yield will remove 4 pounds of P2O5 and 8 pounds of K2O. So the P2O5 removal is 23 tons per acre times 4 pounds P2O5 per ton, or 92 pounds P2O5 per acre. The K2O removal is 23 tons per acre times 8 pounds K2O per ton, or 184 pounds K2O per acre. We would put these removal values into the first line of the nutrient balance sheet when calculating manure application rates using a crop removal basis. Once we have the crop nutrient requirements identified, we need to account for other sources of nutrients that will be available to meet the crop needs regardless of the manure that is to be applied. The first source that we account for is fertilizer applied, which is most commonly starter fertilizer or fertilizer applied as a carrier for the burn down herbicide. In this case, let's say that the farmer plans to apply 100 pounds of a 10-10-10 fertilizer blend as a starter fertilizer with the planter. We would enter these nutrients into the balance sheet in the fertilizer applied row. The next source of available nutrients to consider is the residual manure history. The organic N component of manure will continue to mineralize and supply nitrogen crops for up to 5 years after the original application, and this residual N availability needs to be accounted for. There are two ways that can be used to calculate the residual manure N credit. The easiest way is to use Table 1.2-14b in previous versions of the agronomy guide, or Table 1.2-11 in the 2021 version and beyond. This table lists 3 categories of manure application frequency in the past. Rarely, which is less than 2 out of the last 5 years received manure. Frequently, which is 2 to 3 out of the last 5 years received manure. And continuously, which is 4 to 5 out of the last 5 years received manure. Note that if a field only received manure once out of the last 5 years, but that year happened to be the previous year, the residual credit from that manure addition will actually be greater, and the frequently category should be used to determine the nitrogen credit. The columns of this table have to do with the season that the crop which will be using the nitrogen will be growing. For summer crops like corn, grass, hay, or oats, the soil temperatures will be warmer and microbes will mineralize more nitrogen from previous manure applications as compared to winter crops like wheat, barley, and rye. So the residual manure credit for winter crops is lower than for summer crops. There are also columns that can be used for planting double crops, like rye silage harvested in the spring, followed by corn grown in the summer. In this case, the residual manure credit that would be available for the summer crop is split between the winter and summer crops, with approximately 1/3 of the credit going to the winter crop and 2/3 going to the summer crop. Let's go back to our example balance sheet and say that the field received manure applications 3 out of the last 5 years. This would be the frequently category in the table, which for a summer crop like corn silage would be a residual manure history credit of 20 pounds N per acre. Let's enter that value into the balance sheet. Now there is another, more complicated way to calculate the residual manure history nitrogen credit. This method uses Table 1.2-15 or Table 1.2-12 in newer versions of the Agronomy Guide. In this table, there are factors for the fraction of organic nitrogen applied in previous year's manure applications that will be available for the current year crop. These factors mean that 12% of the organic N applied in manure 1 year ago will be available in the current year, 5% of the organic N applied in manure 2 years ago will be available in the current year, and so on. Let's take a look at how we would do this calculation if, for example, dairy manure with 17 pounds organic N per 1,000 gallons was applied in each of the last 3 years at a rate of 6,000 gallons per acre. For manure applied 1 year ago, we would take 6,000 gallons per acre applied times 17 pounds organic N per 1,000 gallons times an availability factor of 0.12 for 12.2 pounds per acre of available N. For manure applied 2 years ago, we would multiply by a factor of 0.05 for 5.1 pounds of available N per acre. For manure applied 3 years ago, we would multiply by a factor of 0.02 for 2.0 pounds per acre of available N. Adding up the available N from these 3 previous applications, we get 19.3 pounds per acre of available N. It's a more accurate way of doing the calculation for the residual manure history and gives us a result that is still fairly close to what we get when using the simple lookup table based on frequency categories. The next source of available nitrogen that we need to credit is from previous legumes in rotation. Legume crops have root systems and crop residues that are rich in nitrogen. When we rotate out of these crops, the nitrogen left behind in the legume crop residues will mineralize and supply some nitrogen to our current crop that we need to account for. Table 1.2-6 in older versions of the Agronomy Guide and Table 1.2-4 in the 2021 version and beyond lists the nitrogen credits to take for different previous legume crops. For alfalfa, clover, and trefoil hay crops, the credit depends on the percent stand of the hay crop and the soil productivity group, which you can look up in a soil survey or in Table 1.1-1 of the Agronomy Guide. The greater the percent stand or the higher the soil productivity group, the greater the legume N credit is because more residues are left behind from higher biomass crops. For soybeans, the legume N credit is just derived from the yield of the previous soybean crop. Each bushel produced by the previous soybean crop generates a 1 pound N credit for the next crop. Note that the N credits in this table should only be used for credits towards the N requirements of summer crops like corn, oats, or grass hay. Let's go back to our example nutrient balance sheet for corn silage. This corn silage is following alfalfa, and let's say that alfalfa crop had a 25 to 49% stand remaining and was on a moderate productivity field. So the previous legume nitrogen credit would be 70 pounds per acre. We can enter this value in the row of the balance sheet for previous legume N. Now we've got all the sources of nutrients that will be available to the crop regardless of the current manure application accounted for. The next step is to subtract these sources of available nutrients from our crop requirement, which was based on either a soil test recommendation or a crop removal value. Subtracting these sources of available nutrients from the original crop requirement gives us what we call the net nutrient requirement, which is the quantity of nutrients that we can supply to the crop with the current manure application. Let's look at our example nutrient balance sheet. Our original N requirement based on a soil test recommendation was 160 pounds N per acre. We subtract 10 pounds N available from the starter fertilizer, 20 pounds N available from the residual manure history, and 70 pounds N available from the previous legume to get a net nutrient requirement of only 60 pounds N per acre. This is the amount of N that we can apply through manure without exceeding the crop requirement. For phosphorus, we take the soil test recommendation of 30 pounds P2O5 per acre and subtract 10 pounds P2O5 applied as starter fertilizer and have a net nutrient requirement of 20 pounds P2O5 per acre. Applying more than 20 pounds P2O5 per acre would exceed the requirements of the crop based on the soil test recommendation. For potassium, our soil test recommendation indicated we didn't need to add any K2O because soil test levels were already above optimum. So any K2O added will be in excess of the requirement. The 10 pounds K2O applied in the starter fertilizer subtracted from 0 gives us negative 10 pounds K2O. The negative indicates an excess quantity of nutrients applied. Any additional K2O added in manure will keep adding to the excess K2O level. So now you see how we complete a balance sheet down to the net nutrient requirement. In the next video, we'll discuss how to determine the nutrients available in the current year's manure and calculate an application rate that meets the net requirement.